Mach number, Mach, M-A-C-H. It's not match, remember. M-A-T-C, that is pronounced as match. It's a Mach number. Mach number is velocity of any object divided by the velocity of sound. Medium should be common for both. If you are taking the velocity of an object in a medium, velocity of sound should also be considered in that very medium. You see, when it's not mentioned, medium is not mentioned, then obviously we'll consider that for the air only. Mach number 1, if you say Mach number is 1, that means body has the velocity equal to that of sound. It will be known as sonic velocity. If it is less than sound, it will be called subsonic, and if it is greater than sound, it's going to be supersonic or hypersonic. Whenever the Mach number is greater than 1, obviously it's going to be supersonic. As example I have given, if Mach number is 3, obviously the velocity is going to be 3 times. You multiply 343 by 3, you are going to get 1029 meter per second. So, just by knowing the Mach number, we could classify, like it is called supersonic jet or hypersonic jet. It stands for the same thing, velocity greater than that of sound. Now, what is echo? Echo is the reflecting sound. I am speaking something, and suppose you are standing near a wall. My voice will reach you directly, and if it is reflected from the wall, that will also reach you and me as well. I am the source of sound. I am speaking. The voice goes to reflector and returns back to my ears. This will be known as echo. Echo means the reflected sound heard by the source himself. If the reflected sound is going back to the source, this will be known as echo. Suppose this is the reflector. It is the source. The distance is d. Sound goes this way and return. That means it has covered the distance 2d. And velocity of sound is v. Then in that case, the time taken is going to be 2d upon v. You see, you must be aware of one important phenomenon that's known as persistence of hearing. Persistence of hearing means whatever sound you hear on your ears that persists, that remains, that continues for 0.1 second. It is said that persistence of hearing is 0.1 second. So, if I have spoken some word over here, I'll go on listening to it for 0.1 second. If I want to hear the echo distinctly or clearly, obviously the echo should return after 0.1 second. That means this time, in order to hear the echo clearly, this time should be less than or equal to 0.1. If we put this value here, t equal to 0.1, we are going to get the distance d. That means in order to hear the echo clearly, what should be the minimum distance of the reflector, that you could calculate by using this relation, that comes out to be 17.15 meter approximately. Similarly, suppose you are standing unsymmetrically between two parallel cliffs. You are standing unsymmetrically, means not exactly in between. You are here. So when you speak, the waves will go, return. Suppose this is distance d1 and sound has returned after t1, then it's going to be d1 2d1 upon v1. This is the time after which you will hear the first echo. Similarly, second echo will return from second reflector, and time taken is going to be 2d2 upon v2. Why calculating the two time intervals or the two time? You could find d1 and d2 because you know the velocity of sound is common here, v1 and v2, same wave, that is velocity of sound. By putting the value of velocity of sound, we could calculate d1 plus d2, and that's going to be the complete distance between the two parallel cliffs.